Okay, look, I moved this doll right here. That is a scalar movement because I can see I moved it 3 inches. Notice when I show my compass, now you know I moved it 3 inches to the east. That's a vector. So let's go ahead and talk about what magnitude is. Magnitude was the 3 inches that I just showed with my doll head. So that is going to be like the size of the movement. It's also known as the speed. Vector is magnitude, but it lets you know where it went. Like my doll head moved 3 inches, but where did I move my doll head? Towards the east. So let's go ahead and knock out some vocabulary. Many physical quantities such as speed can be completely described by a single number called a scalar. And the number indicates the magnitude, the size of a quantity, how much changed, what happened to the quantity by the size. And then a vector is a quantity that has both scalar and magnitude. I'm sorry, both magnitude and direction. Both magnitude and direction. All right, let's go ahead and take a look at these examples here. So number 1, a boat is traveling at 15 miles per hour, but we have no idea where the boat's going, so we know that's just scalar. Let's look at number 2. A hiker is walking 25 paces where? East. That is a vector. A person's weight on a scale, that's just scalar. Like we can't even determine where on that. But a parachutist is falling straight where? Down. So number 4 is a vector. One more thing, remember scalar kind of sounds like scale. It's kind of hard to determine where a scale is going. That's why it's called scalar. All right, so let's look at the component form of a vector. The component form of a vector is just where the vector ends up. So we're going to start looking at a vector from a perspective of a coordinate grid. A vector is always going to start at the origin. But just remember that the component form of a vector, very important you know the word component. The component form of a vector describes the vector at a single point, basically where it stops. And order does matter. And remember, since we're talking about a coordinate grid, it's really like how many spaces away from point A to point B. All right, let me show you what I'm talking about here. So we're going to find the component form of a vector with the following initial and terminal points, then sketch the vector in standard position. So we're going to sketch that a little later. Now look at my arrows. We always use this. This is known as a vector symbol. Why did I put a 7 there? I put a 7 there because that's how many spaces away it is from -4 to +3. Look at the -7. Where'd the -7 come from? That's how many spaces the y coordinates moved. The y coordinate started at a 2 and then it moved all the way down to -5. That is a total of -7 movements. It's negative because it went down in the negative direction. Let's go ahead and take a look at number 6. Find CD if C starts at this point, 0, 8, and D starts at -9, -3. All you do is just combine the 0 and the -9, which of course is -9, and then you combine the y coordinates. The y coordinates were 8 and -3. Okay, let's go ahead and look at the next one. For the next one, we are going to talk about unit vectors. For now, all you need to understand is that we have horizontal unit vectors and we have vertical unit vectors. I know this is a horizontal unit vector because the 1 is first. Look, this one has the 1 second, so I know that is a vertical unit vector. It just shows movement. All you need to understand is it shows one movement vertically, one movement horizontally. All right, let's go ahead and look at this first one. So what we're going to do here is we are just going to find how many spaces away and find the component form from the initial to the terminal point. Now remember, I started at 0 for my x coordinates, so 0 to 3 is 3. And then for my y coordinate, I started at -2 and then landed on a +6. So that was 8 spaces in the positive direction. All we're going to do is you can just kind of consider the 3 and 8 as coefficients. So this is going to be 3 stuck next to the letter I because that was the horizontal movement. And then 8 is going to be stuck next to the letter J because that was the vertical movement. And that is just it. We're just getting used to some different ways of showing movements and directions. Let's try the next one. All right, so it starts at -6, +4, then it stops at 0, 1. So let's go ahead and take a look at the component form. So let's write our little setup here. -6 to 0 is +6. 4 to 1 is -3 direction there. So remember, those behave just like coefficients. Just make sure you put the 6 with the horizontal I and the -3 with the vertical J. All right, next is order or vector operations, which is kind of like order of operations. All we're doing here is just combining like parts. So if I need to add, then I'm going to add the x coordinates together. Then I'm going to add the y coordinates together. You're just combining corresponding coordinates. That's it. All right, so let's go ahead and take a look at this one. So given vector v at -2, 5 and w at 3, 4, we're going to add those together. So I'm going to show this all spaced out. If you guys can do this in your head, then certainly do it in your head. If you know that 3 and a -2 is going to give you a 1 for the x coordinate, then you do not have to show work on that. That's just a 1. 4 plus 5 is 9. So when we add those vectors together, the addition of those is just 1, 9. All right, but let's take a look at number 8. Number 8 has 3 parts. So we've got part A, part B, and part C. Okay, so for part A, it's going to be 2V. Part B is going to be W minus V, and C is going to be V plus 2W. All right, back to 2V. So when you see a number in front, it's kind of like distribution. We don't really call it distribution, but it's pretty much the same as operation. But we call it scalar with vectors. You're just going to distribute a 2 to both the x and the y coordinate. So that's just going to turn into a -4 and a 10. So when there's a number out front, you just distribute. For part B, we're going to do W minus V. You're actually going to distribute the negative also, just like you would if we were trying to subtract binomials. So remember, W is going to be at 3, 4, and -V, right now V is going to be at 3, 4. I'm sorry, V is going to be at -2, positive 5. Just change the signs when you subtract. So once we change the signs when we subtract, it is going to be 5 and then -1. All right, last one, our multi-step problem of V plus 2W. Okay, so remember V is just V at -2, 5, and we're going to double the coordinates for W. So look, I wrote 6, 8, and we're just going to combine straight down. So 6 and -2, and then 8 and 5. So that's just going to be a 4 and a 13. Okay, we're going to do the same thing again, but this time we're going to be writing it in unit vector form. And I know I have to write it in unit vector form because I see the letters I and J. I is always the horizontal unit vector, J is always the vertical unit vector. We've got 3 parts again. All right, here we go. Part A is 2V. So when I look at this stuff, let me go ahead and write down the rest of these instructions. All right, here we go. So we're just going to take it and we're going to write it in component form. So I'm going to drop the whole I and J for a moment. I'm just going to double those values. Remember, it's V here. So that's going to turn into 8 and -14. And I could leave 8 and negative 14 if it started out in unit vector, or if it started out in component form, but it didn't. It had the letters I and J, so my answer has to have I and J. So remember, those are just coefficients. All right, let's do W minus V. Remember, you're going to distribute the negative here. All right, so a -2 and a -4 is a -6. Remember, that's your horizontal. And 8 is going to be your vertical. All right, for part C, it's going to be V plus 2W. There's plain V. Let's go ahead and double the values for W. All right, so look, when we combine straight down, those 4's are going to cancel out. Just show that there's 0 horizontal vectors plus, or I'm sorry, let's write minus because it's -5. So we are going to show that 0 there, guys. Okay, that is going to be it. The rest of your homework, let's talk about what your homework is going to be. We're going to submit that on Canvas. So your homework is going to be pages 5 through page 5. Just page 5. Please complete all of page 5, and that is going to be a Canvas